This is the second video of a series of 3 about the intercom project using vacuum tubes. As an introduction, we will take a look at the internal elements of a vacuum tube. The tubes we are going to use in this project are a triode, 3-element tube, and a pentode, a 5-element tube, used as the power output stage driving the loudspeakers. On the other hand, we are also using a pair of identical transformers. One of them raises the input signal voltage before applying it to the triode grid, taking advantage of the fact that the grid practically does not load the signal at all and therefore does not weaken it. The triode is the first amplifier tube that was invented. It consists of a glass bulb with 3 elements or electrodes inside. The triode we will use is identified as a 6AV6, which in the 1950s was widely used as an audio amplifier in radio receivers. In this diagram, electrodes are identified by their most common names: cathode, grid, and plate. The cathode of each tube is heated by a small filament, which receives power from the 6.3 volts AC output of the power supply. With that, the cathode heats up and begins to emit electrons, which are kept next to the cathode in the form of a cloud. Being the grid very close to the cathode, it exerts a very large control over the electron cloud, and with a very small signal between cathode and grid, the tube can deliver a signal amplified almost 100 times in the plate circuit. As technology advanced, improvements were made, usually by adding grids. In addition to the control grid, a screen grid helped to avoid unwanted interaction between the output signal and the input signal. After that, the suppressor grid was added to prevent secondary emission of electrons from the plate. This other scheme presents us with a 5-element tube with their respective names. This tube was called a pentode. In our project, we will use it as a power output amplifier with the identification number 6AQ5. The triode tube acts as a preamplifier, which in turn drives the output tube, providing enough power to drive a 5-inch speaker. Let us now look at the way the triode output signal is coupled to the pentode control grid. The coupling is done using a capacitor. In this diagram, we can see the voltages present at both ends of the resistor connected to the triode plate. Suppose the triode is not conducting at all at this time between its cathode and plate. At both ends of the resistor, we can measure 150 volts DC. This causes the coupling capacitor to remain charged at 150 volts. Its left plate being positive and its right plate being at 0 volts. If we place a positive going signal in the triode grid, there will be an intense current between its cathode and plate. With this, there will be a significant drop in the plate resistor. Imagine that the drop is about 40 volts. Now we will have on the left plate of the capacitor a voltage of 110 volt DC. The capacitor acts as a small battery with a charge of 150 volts DC. Since its voltage opposes the plate voltage, it is subtracted from the 110 by placing a voltage of -40 with respect to the negative of the power supply on the right side plate of the capacitor, and therefore on the control grid of the pentode. Thus, the conduction of the triode results in a negative going voltage in the pentode grid. We can see 2 results out of this action. First, the signal has undergone a phase inversion by reversing its polarity. Second, the signal at the output circuit of the triode has been amplified. This is called voltage amplification. The pentode, on the other hand, will carry out an additional amplification that, given the configuration of the circuit, is called power amplification. If we feed a negative pulse to the grid of the triode, the plate of the triode will deliver a positive going signal. While the signal is thus alternating, the capacitor will transmit the variations to the pentode grid, while preventing the 150 volts from being applied directly to the pentode grid. The plate current of the pentode passes through the primary of the audio output transformer, inducing in the secondary of this transformer an alternating voltage that is identical to the signal applied to the input circuit, although much stronger. The third and last segment of this project explains the way in which, by means of a switch, the loudspeakers can be switched so one of them works as a microphone and the other as a loudspeaker. I will shortly finish the video that explains the conclusion of this project. Bye.